section, and in this section I'm going to talk about the random number generator problems, and these are the different techniques for generating random numbers. And so we're gonna see about the three different techniques in the linear congregation method. And in the linear congregation equation, to generate the random numbers is xi plus 1 is axi plus c into mod m. So we'll try to see and understand how to generate this equation by just solving some problems. So I'm just asking the question, generate a sequence of, let me just go ahead and write the equation. So random number generator equation. So this is a linear congregation equation or mixed congregation, linear or mixed. So both are same. Yeah. So I can say equation because it's an equation. Yeah. So I'm saying that generate a sequence of three random numbers. Three random numbers means, so I have to generate 3 R1. So it should be R1. So same thing. So I have to generate R1, R2, R3. So in order to find R1 and R2 and R3, first let us find what is Ri. I have the equation of xi plus 1. This is called the mixed congregation equation, where from this equation where A represents or A is called constant multiplier because it's multiplying with xi, which is nothing but a linear congregation, constant multiplier, and xi is nothing but the value of x0 or x1, and x0, the first value that is going to initial value or seeding value. So I can just say x0 is called is initial value, or I can just call it seeding value. So I'll just make it so that it will be easy. Yeah. Where A is called the constant multiplier, x0 is called the initial value or the seeding value, and C is called increment, and Ri is called the random numbers. Ri is called random numbers. So these are the values, these are the things that we need to know in order to solve the equation. What is A, what is C, and what is M, and what is M. I forgot. M is called modulus from this equation. Yeah. Before solving this problem, let us try to understand how to solve the how to calculate modulus. To calculate modulus. So if x mod y, case 1, if x is less than y, then answer x mod y answer is x. Second one, x mod y case 2 if x equal to y, then x mod y becomes, answer is 0. For this equation, like example, I can just give an example. If 4 mod 5, here clearly the 4 is less than 5, the answer becomes 4. Yeah. Then the next one example is 5 mod 5, both are same, x equal to y, then answer becomes 0. In order to prove it, I can just make another one like 7 mod 8. 7 is less than 8, the answer becomes 7. It's 8 mod 8, x and y are same, it's 0. Then next, x mod y case 3. It is case 2, case 3. Yeah. If x, I will just make it, it's not modulus. Yeah. If I will just calculate modulus. If x is greater than y, then you have to divide and then make sure. Suppose if I say 15 mod 5, so how it becomes is, what I have to do is, now I have to divide 15 divided by 5. So what I can do is 15 by 5, or I will just make it easy. If it is more, then what you have to do is you have to divide 5 by 15. So what I can do is I can just say like this, 5, this one is 15, or I'll just start 5, and then I put 15 here. So I will do division. So 5 3s are 15. Whatever the remainder that I am getting, it should be the answer. The modulus is nothing but the remainder value when you divide it with the x value. So the remainder is 0, 15 minus 15, and this is the answer. So remainder is the answer. So same thing, if I say 15 mod 9, now what I will do is 9 I should divide 15, and whatever the remainder that I get, it should be the answer. So same thing, I put 9, I put 15, and how many times it goes, it should be the whole number. So 9 ones 9, so 15 minus 9 gives you the value of so 6. So here 15 mod 9 gives you 6. Yeah. So this is how you calculate the modulus, and these are the values for the constant multiplier. Initial x0 is called initial or value or seeding value, c is called the increment, and ri is a random number. So I am just asking to find the 3 random numbers. In order to find the r1 also, ri, to calculate ri, random numbers also, there is a formula. So ri is nothing but x I xi divided by m. So this is the value to calculate the to calculate the random numbers. So this is the, so I'll just put, yeah. Now I need to find the case 1, case 2 and case 3. So case 1, so I need to find 3 random numbers in mixed congregation. So mixed means or linear, it's same. So mixed congregation method, it's nothing but case 1, C is not equal to 0. C is not equal to, so in the mixed congregation equation, the equation becomes, so the same equation xi plus 1. Now I need to find x1, x2 to find the R1, x1, x2 and x3. So x1 is nothing but xi plus 1. I becomes here xn plus 1. N becomes 0 here because I need to find x1. So I need to substitute for n equal to 0. So the equation that I given is, I'll just change the values here because I just want to make it easy, is 16, it should be 11 mod 7, no problem. Yeah. Now from this equation, what does A is 11 and AXI plus C is 16 and M is 7. So these are the initial constant multiplier, increment and the modulus. So I got it. Now to find what is x0 given from this equation, x0 is 17. So I can just, 0 is 17. Yeah. Now to find the x1 is nothing but 11 into, so here x1, to find x1, n becomes 0. So I need to substitute n equal to 0. So 11 into x0. x0 is 17 plus 16 mod 7. So it's nothing but 11 into 17. It's nothing but 187 plus 16. It's 187 plus 16 mod 7. So it's nothing but 187. It's 13. Yeah, 203 mod 7. So x is greater than y, so I have to just do it this one. So divide it with 7, 203. So 203 mod 7, 0. It's 7. I think 203 mod 7 should be 203 mod 7 becomes 0. I think so. Yeah. The next one I need to show is x2 for n equal to 1. So for the x2, n becomes 1 here. So here 11 into what is the x1? 0. 11 into 0 plus 16 mod 7. So 11, so 16 mod 7. So 16 is greater than y, so x mod y. So what is the, you have to divide it. So 7, it should be 2. Yeah. Next one, x3, here n equal to 2. So here n equal to 2, 11 into 2 plus 16 mod 7. So it's 22 plus 16, 32, 38 mod 7. So 38 mod 7 divide 7 5s are 35. So you can just divide it 7, 7 5s 35. The remainder that you're going to get is 3. Yeah. Now I need to find R1. R1 is nothing but x1 divided by m. So x1 is how much? It's 0. So it will be 0. Next one is R2. R2 is nothing but x2 divided by m. So x2 is 2 divided by 7. So 0.2. R3 is nothing but x3 divided by m. So 3 divided by 7. Yeah. So these are the things that you need to do for the mixed congregation. Now I'll go to the case 2. Is nothing but multiplicative congregation method. Multiplicative congregational method. So in the multiplicative congregation method becomes when C equal to 0. From this equation, from equation 1, when C equal to 0 becomes AXI into mod M. So this is called multiplicative congregation equation. So I need to find x1, x2, x3. So x1 is nothing but A. A is how much here? A is 11. 11 into the initial value will be 0 because xi plus 1. So here x1 in order to calculate. So n is equal to 0 because you are just putting the value for the n. So I should be 0. So it becomes A is how much? A is 11 into x0. x0 initial value is 17 and mod m. So it's nothing but 11 into 17, 187 mod 7. So 5 because 7 2s are 14, 7 6 are 42. The remainder from dividing with 7, 187 is 5. And the same thing here I can just do. R1 is nothing but x1 divided by m. The R1 will be the same always whenever you're doing. So it will be like 5 divided by 7. Yeah. Next x2. So it's I equal to 1. And here I'm just saying 11 into how much? It's not 11 because I is 1. So x1 becomes x1 becomes 5 into 17 mod 7. So 17 5s 85. So 85 mod 7. So 7 1s 7 2s 14. So how much? 7 1s 14. The remainder is 1. Yeah. And the next one is R2 is equal to x2 divided by m is nothing but x2 is 1 divided by 7, yeah, 0.4. So this is how you need to calculate for the three things. Next, case 3 for additive congregation method. Congregational method for a equal to 1. So in the additive congregation method, a becomes 1. So what happens from this equation? Axi plus c, when a is 1, so it becomes xi plus c into mod m. So just we need to do the same thing, x1, so I equal to 0. So just in case it have I is 0 is equal to 11. There is no a, so it should be xi. X0 is how much? The initial value is, so x0 is 17, so 17 plus c. What is the c value? C is 16. 17 plus 16 into mod n. So mod 7. So 17 plus 16 is 13. So it's I think so 33 mod 7. So 7 4s are 28, and the remainder is 5. Yeah. And the next one is R1 is x1 divided by m. So x1 is how much? 5 divided by, what is m? The m value for this equation is 5 divided by 7. So same thing, x2, x3, it follows the same principle. Just you have to see the cases. What is the mixed congregation method, and what does it mean? A means, and what is C means, and what is m? A is nothing but constant multiplier. X0 is, or the initial value, it's x0. C is increment, or is a random number, m is a modulus. So in order to calculate the modulus, there are three cases. If x is less than y, x is greater than y. And there are three cases for the mixed congregation equation, and to calculate the random numbers, just use the formulas and then you will get those numbers. So this is to generate the random numbers, and there are two more tests to test the frequency test. One is uniformity test, one is a KS test, Koglomorov-Smirnov test, and the other one is chi-square test. So what I will do, I will just the random number generation. Yeah. So these are the frequency test to check the uniformity of distribution. For all these tests, one thing you have to see the property, they are all uniform and independent in nature. Whenever you are trying to do the test to check the uniformity, they are all uniformity and independent in the interval range from 0 to 1. Independent. So let me just go ahead and just get this formula, because so this is to calculate the chi-square test formula, where just understand the formula, where OI is nothing but observed values. OI is nothing but observed values, and EI is nothing but expected values, and I is 1 to n, whatever the summation. So we have two events here, two heads and tails. So I'm just asking, given below the observed and expected values of flipping of 80 coins, perform chi-square to check the uniformity of distribution. So I want to check, and the critical value that is given is, so you know this formula, when x0 square, so the condition is if x o square square is less than the critical value is less than the critical value less than or equal to critical value, then uniformity distribution is accepted. If it is greater, if x is rejected, uniformity distribution is rejected. So these are the conditions. So I will just get these values, get this table, it will be easy. And solution for the first one for chi-square test. Okay, I'll just make it as E1 and this is E2 and E2 and this is O1 and this is O2, because these are the observed values and these are the expected values, because the formula is summation O1 minus E1 square. So the formula to check the uniformity distribution is nothing but summation of this one. So what I have to do, so it's nothing but O1 minus E1 square so the square is I'll just O2 minus E2 square, so O1 minus by EI, so divided by, so it will be, so divided by E, so first one is E1, next the summation is O2 minus E2 divided by EI, so the second one is E2. So nothing but O1 minus E1, 32 minus 40, it's minus 8 square, so 64 divided by E1 is 40 plus same thing O2 minus E2, 48 minus 48 minus 40, 8 square, 64 divided by 40, so nothing but 128 divided by 40, 3.2. So the critical value that given is 3.84 and the critical value, it's x0 square is less than the critical value, the uniformity. So now 3.2 is less than 3.8412, uniformity distribution is accepted. It's just to check the uniformity distribution accepted or rejected. So this is what you need to do for the chi-square test. Next we'll see the Kolmogorov-Smirnov test with the alpha is 0.05 and the critical value is 0.561 and generate, and you have to see what is so you know the things. First you need to put the numbers from smallest to highest and then calculate the d plus and d minus and take the maximum number and compare it with the critical value. So if you find it less than or equal to critical value, then uniformity distribution is accepted. It follows the same chi-square test. Chi-square test is for calculating the square of the numbers, and the KR test is for just checking the random numbers in the interval can be rejected or not. So why we are saying in the interval 0 to 1 is you can see the numbers that are being generated from the range from 0 till the end of 1. So I will do KR test here. KR test. So I will insert So first thing I have to do is I is nothing but the numbers. I want to, how many numbers are there? 1, 2, 3, 4, 5. Total 5 numbers are there. I'll just put it from smallest. I'm just arranging. Next, I have to calculate Ri. R I is nothing but, so I have to arrange the numbers, random numbers R1, R2, R3 and R4. So R1 is nothing but the lowest number of this one. So I'll just, it will be easy instead of going. Yeah, the lowest number is 0.19. Next 0.34. Next 0.72. Next 0.85. Next 0.72. 0.91. Next I need to calculate D plus. D plus is nothing but maximum of Ri. So I'll just say this one. Ri minus I. Before calculate this one, I will have to calculate I by n also. So I will just say I divided by n. I is nothing but given, and the total n is nothing but total number of numbers in this test. So it's 1 divided by 5, and here 2 divided by 5, and 3 divided by 5, and here. So I have to just put the total number. Now I need to put D plus. So I have to, what I have to do, I by n minus Ri. So first is I divided by n minus, it should be minus Ri. And this is maximum. D plus is nothing but maximum value I have to take. So first I will take I by n minus Ri. So it's nothing but 0.2 minus 0.19, 0.01. So this one minus this one, 0.4 minus 0.34. So 0.6 minus 0.72 minus 0.1, 0.8 minus 0.85 minus 0.05, 1 minus 0.91. I'm just removing from the I by n minus the random numbers, and the next one is D minus. So it's Ri minus just put I minus 1 divided by n. So this is a formula to calculate. So nothing but Ri is 0.19 minus I minus 1. I by n is 1 divided by 5. I minus 1 is nothing but 1 minus 1, 5, 0. It's 0. So it will be 0. Yeah. Next, Ri, I minus 1. I minus 1 becomes, it's 2 minus 1. So 1 divided 0.34 minus 0.2. So just check this, check this in the cross order. You can just able to find this. So 0.34 minus 0.20. Yeah. Next 0.72 minus 0.4. Next 0.85 minus 0.60. 0.91 minus 0.8. Okay. Now from this I have to calculate D and D plus. So D is nothing but first I have to find D plus. What is a D plus? Is nothing but it's a maximum value of this one is, it's I think so 0.0, 0.12. 0.12 is minus 0.09. D plus is, and D minus is nothing but maximum value of this. So it's 0.32, and D is maximum between these two, maximum of D plus and D minus. So it's nothing but maximum of 0.09 and 0.32. It's 0.32. 0.32. Yeah. And the critical value they given in the question is 0.565. Critical value 0.565. So now I need to find D is less than D critical value, then the uniformity test is accepted. So this is how you need to do the generation for the random numbers. So this is for the frequency test. One is a chi-square test. So to calculate the chi-square test, summation of observed minus expected divided by expected values. And to calculate the KR test, we have seen in the as we have seen in the discussion, which is IR should be I divided by A. Yeah. Yeah. So this is how you need to solve the problem. And if you do have any kind of questions or concerns, please just post it in the comment sections. And I hope you got some basic understanding on the random number generators. And this is how you need to solve different kinds of problems related to the random number generators. Thank you for watching the video. Have a nice day. Take care.